Okay, so hi guys. So I'm gonna be doing paper 1 Kedah 2025, and I actually did some of these questions yesterday before I slept. So let's do this. So first question asks which of the following base quantity and its SI unit is true. So the answer is B because base quantity is time and the SI unit is S. For base quantity, yes, mass is one of the base quantity, but this is not the SI unit, it should be kg. And the length, it's supposed to be meter. And temperature, it's supposed to be apa? Is it like Kelvin or something? Let me check. For temperature, yeah, it's supposed to be Kelvin and it's called thermodynamic temperature. But I feel like that doesn't really matter if it's thermodynamic or just temperature, it should be Kelvin. Okay, next. Diagram 1 shows an arrangement of apparatus to investigate the relationship between the length of simple pendulum and the period of oscillation. Which pairs of variables are correct? So they want to investigate the relationship between length of simple pendulum and period of oscillation. We already have the answer based on the question itself. The answer is length of pendulum, and responding variable is period of oscillation and mass of bob. Why? Because if you've done this experiment before, I'm pretty sure all of you must have done this experiment before. We change the length of the pendulum, meaning that we go from 5, 10, and maybe 15. So the things that you change, which you are manipulating, is called a manipulated variable. Next. Diagram 2 shows a car moving with a velocity of 20 milliliter per second. The car slows down when approaching a red traffic light, and the car traveled for 50 meters before it stops completely. Okay, so this we have to use the Satuf method, and I'm going to open the textbook to find the formula. Okay. So here, always list down what you have. So we are given velocity, so 20, slows down when it approaches a red traffic light. This should be initial velocity then. Jump. So this is your initial velocity. Final velocity is 0 because it slows down. And then the car traveled for 50 meters before it stops completely. S is equal to 50 meters. And what does it want us to find? They want us to find the acceleration of the car. Okay, so we have this formula that we can use. V squared is equal to U squared plus 2GS. That's free fall. 2AS. 2AS. Okay. So 0 square is equal to 20 square plus 2A bracket 50. So click your calculator and you'll get negative 400 is equal to 2 times 50, 100. So this is, so A is equal to negative 4 ms negative 2. Is the answer C? Yep. Okay, so make sure to list down everything so that when you're going to substitute, you don't get confused. And make sure even if you get a negative number, it's still normal, because for acceleration, it's a vector quantity, meaning that there's negative and there's positive. So this answer is still normal, meaning that because the car itself is decelerating, so if you got a positive number, then your answer is probably wrong, meaning that you probably switched u and v. Next, diagram 3 shows a graph of changes in displacement with time t of an object. Okay, which velocity graph represents the same motion as the object? Okay, I've already done this. Okay, so I'm gonna write the formula d, s, and t. So right now we are looking at the graph for displacement and time. Okay, wait, no, this is distance, speed, and time. Okay, I'm gonna change that and I'm gonna use the s, v, t. Okay, so right now we're looking at s and we're looking at t. So the definition of velocity is equal to rate of change of displacement, because anything that has a term rate of change, even in maths, you always pair it with t, right? So that's why from the formula itself, you know that it's called rate of change of s, or in this case, displacement. Meaning that displacement has to be increasing or it has to decrease. So in this case, this indicates that the object is stationary. So it's stationary. This means that if it's stationary, there's no displacement, so velocity is equal to 0. And here it's increasing, so velocity is uniform. And this also decreasing at a constant rate, so v is uniform. So kalau you want to sketch a graph, then if it's 0, then v would be here. Kalau uniform, it would be here, and then it would be like this or something like that lah. So the answer is, oops, my bad, bukan dekat sini, because it's decelerating. It should be dulu lah kan. Okay, so like bawah there. So the answer is B. Okay, next, a trolley X of mass 6 kg and velocity of 3 ms negative 1 collides elastically, meaning that they don't combine, with another trolley Y of mass 3 kg and velocity 2 ms negative 1. If trolley X stops, okay, this is X, this is Y. If trolley X stops immediately after the calculation, so this is U, this is U, this is U2. So trolley X stops immediately, so final velocity is negative S. Calculate the final velocity of trolley Y. So this is the principle of conservation of momentum lah, I guess. So m1v1 minus mu is equal to m2v2 minus m2u. Okay, so just substitute these values. So then you'll get negative 24. I bawa sini siap-siap is equal to negative 3v2. So v2 is equal to 8 ms negative 1. Okay, so 5, the answer is C. Next, diagram 4 shows the force time graph acting on an object. The impulse of the object at t is 1.0. The impulse of the object at t equals 1.0 is, so they want to find the impulse here. So impulse is a change of momentum, and the formula is mv minus mu. So it's equal to 1200. Ni dekat sini it's 0.4. 4. Rate of change of force is momentum. Okay then, so this means that we have to find the gradient. So 12001. Is it 1200 NS? Is it D? No, it's not. Ke dia ambil no, salah lah. It's like this, yeah. Okay, got it already. So we have to find the betul lah. So we have to find the area, because it's not, I was confused because I did the gradient itself because it's F over T, but the relationship, because M, or in this case impulsive force, is equal to NS, so we have to times F and T. Now that makes more sense. So 1 over 2, oh, I already wrote it down there. 1 over 2 times 0.6 times 1200 is equal to or should we? Okay, so for this one is equal to 360. This one is equal to 240. So 360 plus 240 is equal to 600 NS. Oh, so it wants the impulse of the object at T 1.0, so they want the whole thing. This whole thing. Okay. Sure then. So the answer is C. Okay, next. Oh, I did this yesterday. My own careless mistake. This is quite easy. I just forgot that the formula for gravitational is Gmm over r squared. So all you have to do is just substitute. So two objects A and B, each with masses ma and mb, are placed at a distance r from each other, and if the gravitational force between the two objects is F, what will happen to the gravitational force if the mass of object A is double and the distance between the two objects is half? So you just substitute lah, and then you pindah-pindah and you get 8 AB over r squared. So the answer is the gravitational force becomes 8 times greater. Okay, Kepler's second law. Kepler's second law is about like equal areas that equal something. Equal areas and time, you know. Equal areas in equal intervals of time. Yep, this one. 8D. The major axis is equal to the planet's average distance from the sun. It's none of the Kepler's law. The square of the orbital period is directly equal to the cube of the cube of major axis. This color radius, that's Kepler's law, so none laws. The orbit of a planet around the sun is an ellipse with the sun at one focus. I remember something about one focus being like the first law or something. but I don't know if that definition is accurate. Diagram 5 shows the MESAT satellite in an orbit with distance 613 kilometer. Do they give kilometer or meter? Okay, so change siap-siap to meter. So kilometer to meter tambah times 1000. So you get 613,123 meter. Earth, the radius of the Earth. Okay, so in this case, R is equal to big R plus H. And the mass of Earth. Okay, so what is the linear speed V of the satellite in orbit? Do I remember the formula? Linear speed is different than it's mv square over R. Yeah. So V is equal to 5.97 times 1024. This looks like this is an R. MV. Betul lah? Chincha, is this linear speed formula? I feel like that's centripetal force. Wait, linear speed formula. What's it? Oh. GM over R. If it was there's linear speed and then there's linear speed and then there's escape velocity. One of them is different from the other. Like there's like a difference. Wait, I have to remember. There's like a difference between the two. You know what? I give up. I'm gonna open my book. Oh my god, I thought my pen fell. Yeah, betul lah, this is the formula. So this is the formula for linear speed. Tapi there's another one. There's another one other than linear speed, or am I tripping? I'm yeah, kalau escape velocity ni linear speed. This is linear speed. Tapi kalau escape velocity, you have to like put in more effort, I guess. It's the same symbol V, and you put 2gm over R. Okay. So in this case, substitute V is equal to square root 5.97 times 1024 bracket 6.67 times 10 negative 11. Kind of got the M first and G over 613,123 plus 6.37 times 10. Is it 6.37 times 10? 6. Okay, so click your calculator and you'll get the answer. Just a mess, just what you do. Okay, 7551.427575. The answer definitely this because it's the only thing that has 7. Is it right? 9 is C. Yup. Next. Diagram 6 shows two copper blocks L and M in thermal contact. The initial temperatures of L and M are 50 degrees Celsius and 30 degrees Celsius specifically. Which statement is correct when L and M are in state of thermal equilibrium? So thermal equilibrium, remember, needs thermal contact. Pasu apa after thermal contact, the net heat transfer is equal to 0. And temperature of both objects is the same. So temperature, wrong. I don't think we use the term quantity of heat. Rate of heat transfer. Yep, the answer is C. This is definitely wrong. 10 is C. Oh, 10 is C, 10 is C. Okay, never mind. Diagram 7 shows Diagram 7 shows 4 types of liquid P, Q, R, and S of same mass filled in the same type of container. All the containers are placed under the sunlight for 1 hour and cause the different temperature rises. Okay. Which arrangement of specific heat capacity is correct? If the increase in temperature is the highest, meaning that you have low specific heat capacity. Because it means that you cepat panas. So meaning that the lowest would be highest specific heat capacity. Right. Okay, so they want... Oh, so they don't specify whether ascending or descending. So... Well, obviously ada arrow, never mind. So... S is the highest... P is the highest. This is P. This is wrong already. And lowest is S, not Q. So the answer is D. Next. Shows a manometer connected to a gas tank. If the atmospheric pressure is 76 Hg, so from here to here is 76 cm Hg. Which statement is true about the pressure in the gas tank? So this is definitely lower, because this is like pushing more compared to this. Smaller than 76. The answer is A. A, larger. Sorry, itulah smaller. Smaller than 76. Because I was like, wait, why is the answer is C? Yeah, it is C. Shows a load hanging from a spring swinging in water. Which displacement time graph describes the motion of the load? So this is damping. You already can see because the amplitude is decreasing. And it's different, okay? If it was an acceleration time graph, I think. Wait, let me open. Because if displacement time graph, it's easy. You just draw like a loop and it will like decrease in amplitude. Tapi kalau acceleration time graph, then it's also easy. It's just like a straight line and it like decreases. I'm not sure, yeah. Sorry, bukan acceleration. Amplitude. Kalau amplitude time graph, it's like, yeah, let's say this is time and the amplitude is like decreased. Yeah. So kalau displacement time graph, then it's something like this. You go. Yeah, it's B. Because this is like increasing. This is like, which one ada kecil lagi sepatutnya? It's not, it's supposed to be the same. It's supposed to be like this. Next, diagram 10 shows water propagating through a perspex blocks in a ripple tank. Which wavefront pattern can be observed when the waves passes through the perspex blocks? So this is from less dense to dense. This is obviously... Why is the shape like that? So dia akan macam ni kan? This is like diffraction. I don't think it's that's the answer. Is it A? Yeah, it's A. Because logically, if you go from less dense to dense, then it will look something like, you can follow the shape of the blocks. Like contoh lah, if you're in a sungai and then you go from like less dense to dense, then it will like follow the shape of the sungai. Because I came across a question like that before. And if I'm not mistaken, wait, I want to like refresh and see what affects refraction. Color reflection, angle of incidence is equal to angle of reflection. A wavelength and frequency, wave speed, no change, and direction of propagation obviously changes with the condition that the angle of incidence is the same as angle of refraction. Color refraction, angle of incidence, it depends on whether you're going from deep or shallow region. Color wavelength, it's also depends, tapi the wavelength changes. So in this case, it's going from a less dense to dense. so it means that the wavelength will decrease. That's why it's like closer together. Kalau frequency, still no change. I feel like out of all of these, frequency is not affected. It's like just the same. And the wave speed also depends. Like contoh in this case, the wave speed is decreasing because as it goes from less dense, or let's say even through water, deeper you are, less dense. Kalau shallow, you are denser. So if you go for kalau wave speed lah, let's say, it like goes fast, and then main kat sini it's like slows down. Okay. Okay, next. Okay, diagram 11 shows an interference pattern of water waves from two coherent sources. Okay, interference of waves. Which point is the node? Okay, kalau antinodal, I like to remember one, so like the other one is opposite. Antinodal is like the crest and the crest, huh? Jap. Yeah, antinodal is this, I think. Kalau nodal is like connects the crest and the through because it's like the destructive. But I just know the answer is D. It's 15D? Yep, it is. Okay, diagram 12 shows an optical device to see distant objects using a prism. What is the physics concept used in this device? Okay, we already know that this is not a mirror, it's a lens. Kalau lens, it's always refraction. But if they say mirror, if there's mirror, it's prisms, like lens. Okay, if there's mirror, then it's reflection. Okay, that's how I like to remember it. So it's B. 16. Eh? Wait, it's D? Oh, prism. Whoa. This is something new. So, do all prisms like undergo total internal reflection? Let me fact check that. Do all prisms undergo total internal reflection?
Exactly. So a prism works because light is entering from one side, and when it hits the boundary inside at a steep enough angle, it's completely reflected back inside. This happens because of the difference in refractive index. So the light stays inside and moves along the prism, bouncing off the walls, until it exits at another angle. It's a cool use of refraction and reflection.
Ah, because I remember writing down in my textbook, like kalau diamond, it's in total internal reflection. Tapi I thought that we were looking at the lens. Okay, I see. So the answer is D, guys. Okay, this shows an incomplete ray diagram for a concave lens. Among A, B, C, D, which position is the opposite of image form? So concave lens is different than concave mirror tau. Kalau concave lens, it diverges. Kalau concave mirror, it converges. So in this case, kalau diverge, you go out. So I'm just gonna like draw because I don't know the exact, I don't memorize the kedudukan, tapi I know how the arrows work, I guess. So it's B, right? Please tell me it's B. Is 17B? Yep, it is, because this is the point and this is the image. And because like kalau they diverge, then the next is dekat tepi ni. Next, so which of the relationship L, O and M correct for light microscope to normal adjustment? No, I don't remember this. Okay, jap. The focal length of the objective lens and eyepiece lens of a light microscope. Okay, kalau light microscope, you nak pakai nak tengok like bacteria kan. Okay, so let's say there's like a microorganism there. And the eyepiece lens of a light microscope are FO and FE. Split spectrum objective lens dekat sini. Objective. This is eyepiece. Okay, let's say based on logic lah. I'm just gonna try to answer this. Kalau based on logic, kalau objective lens, obviously the image is magnified, right? It's magnified. Is it virtual or is it image? Okay, let's say it's real and inverted, because I keep thinking of wood. Sebab kalau diminish, soalnya virtual kan? Okay, never mind. Inverted. Okay, let's just ignore real and inverted at this point. Just focus on magnified. Kalau eyepiece lens, kalau eyepiece lens, okay, never mind. Okay, the distance between the two lenses is L. Okay, what is the relationship between L, FO, and FM? It's correct for the light microscope. So kalau L, the distance between the two lenses is L. Takkan okay, if the distance between the two lenses is equal to FO plus FM, then the image would be same as object. Kalau the distance between the two lenses L is less than the focal length of O then M, then the object would be diminished ke? But if it's more than, so this is the focal length. This is the focal length of the lenses. This is the distance between the lenses. Is this low-key like object? Because okay, the final image is magnified. I know that kalau object is less than focal length, then frequently it's gonna be magnified. So is it B? 18. It's C. Okay, let's see why. Okay, so the final image is virtual, magnified, and inverted. So it's not real, it's virtual, inverted, and magnified. And the object distance is between FO and 2FO. So distance between objective lens and eyepiece lens has to be more than the focal length of both of them. Okay, I don't know how to relate this to my knowledge regarding object and all, because L is not the object definitely. It's just the distance between objective lens and eyepiece lens. So the more the distance between the objective lens and eyepiece lens is to me that focal length is less, then I guess okay. I'm looking at the diagram. So if it's more than the FO and FE, this means that the FO is shorter. So object place is less than, no, it's more than F. Never mind, you just have to remember this. Okay, next. If the focal length of the convex lens is F, where should the object be placed in front of a convex lens? It's the same as object. It has to be equal to 2F, right? If I don't remember, but it has to be equal to 2F. Because I remember something like equal to 2F. Yep, it's A. Diagram 5 shows a box of mass 5 kg being pulled with a force of F on a rough surface. The frictional force on the rough surface is 6 Newton. I need my drink. OMG, this is the same question that my classmate asked me. And I was like, wait, how do I answer this? And then like that time I wasn't that strong in this chapter, but now I learned more things, and I tried solving it at home and I got it with the help of GPT. Thank you, GPT. The box moves. Yeah, this is the exact question. What is the force F on the box? Okay, I don't think I can recall completely how to do this, so let's do this from scratch and based on what I know now. Okay, so we want to find F, so we have 5 kg, so 5 times 9.81 is equal to 49.05 Newton, and we always like resolve this force into 2 components, right? So then it would be like that, and it would be like that. Okay, no, it would be like that, and it would be like that. So this is Fx, this is Fy. Okay, and the data will always be to Fy and F, and the component that we're resolving. So this is 43 degrees, and I'm trying to find F. So then if I try to solve this, what do I get? So this is, you know what, I tak mau pakai this triangle, I pakai this triangle terus. So this is O. Okay, so I have to use sign. So Fx is equal to 33.45. Okay, so I know that over here it's equal to 33.45. Okay, they want us to find the force F on the box. Tapi apa kaitan Fx ni dengan di F ke atas? Okay, there's no okay, wait, never mind. Okay, they give us acceleration. Okay, I might as well use that. F is equal to ma. So we get the resultant force 5 times 2.42. So F is equal to 12.1 Newton. Oh! Stop, if I minus? 33.45 minus. Wait, how is the component? How is the Fx component more than the resultant force? That's weird. Wait, actually it makes sense lah. Boleh je. Oh, that 12.1 minus 6 minus 33.45. You can each 33.45 minus 6 minus 12.1. No. So that's the resultant force. Okay, you know what? Never mind. Maybe I can find this. If I find this, then I can calculate my F. Okay, so it shows a box of mass 5 being put with force F on a rough surface. So the resultant force of this whole horizontal is 12.1. So 12.1 minus 6, 6.1. So here is 6.1. So then this is this is H, this is O. This is A. So cos for result of force. 18.1. So 18.1 minus 6, you get 12.1. Okay. I got a similar answer. So this is cos 43. So if A tadi I dapat ni sama dengan 18.1 over F. So F would be equal to 18.1 over cos 43. So F would be equal to 20. Yup, I got it. Is it the answer? Finally, is it the answer? Oh, but I don't remember using this method. I used a different method. The answer for 20 is A. Yes! Okay, so basically, I found the resultant force for this box because the friction kat sini. So maksudnya resultant force, so mean that the whole resultant force of the box is 12.1. So logically, kalau I nak cari the force dekat sini, I need to plus with 6 lah, because that's the force yang what do you call it? That's the force that's like opposing the friction. No, frictional force is the force that opposes the active force forward. So this is the active force forward. And basically it's like pulling the friction. So kalau I get resultant force here is equal to this force. Okay, let's say this is called X. So it's equal to X minus 6 Newton. So if I want to find X, I have to plus F plus 6 Newton lah. So X is equal to 12.1 plus 6. So X is equal to 18.1. So bila I dapat 18.1, I can already find here lah. This, just put here. This is H. This is the opposite angle. This is O. This is A. I use trigonometry. And then cos 43 equals A over H. And then you pusing-pusing. You bahagi. And then you get A. Yay! Okay, next. WX. Diagram 15 shows a boy of weight 320 newtons sliding down an inclined plane with an angle of inclination 30. Weight 390. Okay. Here, this is 30. Here, straight. Mesti dia nak suruh cari WX kan. What is the boy... What is the boy slide down with uniform velocity? The frictional force is greater than the component of weight parallel. No. The frictional force is less than the component of weight parallel. No. Weight parallel to inclined plane. C kan? I don't know. 21. C. Yup. Because uniform velocity, resultant force is equal to 0. There's only two conditions when resultant force is equal to 0. When there's uniform velocity and when an object is stationary. Okay, why, you might ask? Because force is... there has to be acceleration. So in order for there to be acceleration, there has to be a rate of change of velocity. Kalau stationary, v is equal to 0. Kalau uniform velocity, acceleration is equal to 0 because it's increasing at the same speed at the same distance. So there's no rate of change of velocity. So if there's no acceleration, then resultant force is 0 lah. Next, the table 1 shows the results of an experiment to investigate the relationship between load and extension when the spring is stretched. The original length of spring is 10.0. What is the constant variable? Weight of load is manipulated variable. Weight of load force is diameter of spring use. Yeah, because this affects the spring constant. 22 is D because right now the spring constant, because the formula is F equals Kx. So kalau we're investigating this and this, then one has to be constant. So in this case it's K. And K is affected by a lot of factors, and one of them is diameter of spring use. Meaning that kalau we use a larger diameter, then the spring constant would be low, and if we use a smaller diameter, then the spring constant would be high. So this means that we have to keep K constant, we have to make the diameter of the spring use constant. What is the physical quantity represented by H? Shows a mercury barometer. So atmospheric, kalau barometer dia pakai atmospheric pressure kan? 23, is it D? Yup, it is. Shows a mercury manometer used to measure gas pressure in an airflow pipe. If atmospheric pressure is given 76 cm/Hg, what is the gas pressure in the pipe? Give you an answer in unit PA. So this is 25. Kalau atmospheric pressure is the whole thing kan? Because atmospheric pressure is here. So meaning that from here to here ke? Okay. 76. Wait, what is the gas pressure in the pipe? Unit 2. So this is gas pressure, this is atmospheric pressure kan? Why is atmospheric pressure so much? Never mind. Okay, take 76 minus 75 and you get 1. So this is 1 cm/Hg. I convert to meter. I get 0.01 meter Hg, and I convert to Pascal. P equals rho Hg is equal to density 13600. 0.01 times 9.81 times 13600 times 9.81. 1334.16. Wait, why are these values dinky? Huh? Why is my value so like low? 136,600 times 0.01 times 9.81. So why I get 13334.16? Yep, definitely an error in my calculation. Kalau gas pressure, then wouldn't it? This is PATM. Tapi at the same time, why is it so like sikit and it's 76? Curve from here to this doesn't make sense. Okay, I need to open my textbook. Betul lah. Okay. So this is 76. And difference in air pressure is equal to height of mercury column. So in this case, this is 76 cm/Hg. Okay, so in order to find this, so pressure of gas is equal to 76 cm/Hg plus height of mercury column, because itulah, this whole thing is pushing the gas. So that's the pressure. So then it's equal to 76 plus 25. 101 cm/Hg is equal to 1.01 meter Hg, and convert it to Pascal using the formula rho hg, so P is equal to 13600, okay, times 1.01 times 9.81. Wait, there's somebody outside. 3600 times 9.81 is equal to 134,750.16. It is somebody outside. Nieces and nephews came for a while to see if they left their kumon bag. Woo. Ouch. So based on this, the answer both in standard form. The answer is A. Sorry, B. Okay, diagram 18 shows a bottle containing a balloon that is accelerating upwards towards the water surface. Which of the following statements is correct? The total buoyant force of the bottle and the balloon is equal to the total weight. Is balloon experiencing buoyant force as well? Is it A? No. No. It's A. Wait, oh, I forgot to check if this answer is correct. 24, B, 25, C. The total of the buoyant force of the bottle and the balloon is greater than the total of the weight. Oh yeah, because it's moving upwards. Unless it's floating, then it would be equal. In this case, it's moving upwards. So meaning that the buoyant force is greater than the weight. Okay. Haven't learned this yet. Haven't learned that yet. Haven't learned that yet. Haven't learned that yet. Haven't learned it yet. Haven't. Wait, banyaknya. Haven't. What is a nuclear reaction that produces energy on the surface of the sun? I learned this. Is it nuclear fusion or nuclear fission? Is it A? It's either A or C. 37A. Yep. Okay, if I open my textbook, page chapter 6, I had like a distant memory. Yeah, the sun provides light and heat energy to Earth since millions of years ago. Hydrogen nuclear fusion occurs in the core of the sun under very high pressure, and in this nuclear reaction, two hydrogen nuclei fuse to form a helium nucleus and release nuclear energy. This energy is radiated to the surface of the sun in the form of light and heat energy, as shown in photograph 6.1. Okay, I haven't learned. Yeah, I haven't learned this yet. What is it? No. Oh, that's it.